morning. A warm greetings to each and every one of you present here. Welcome to International Conference on Multifunctional Materials for Societal Applications, ICMMSA 2025, organizing by Department of Physics, Usmania University. On behalf of the organizing committee, we extend our appreciation for your presence today. My warmest greetings and heartfelt welcome to today's chief guest, Sri Jishnudev Verma Sir, Honorable Governor of Telangana and Chancellor of Usmania University.
I would like to share about the department and its activities. Department of Physics, Usmania University was one of the earliest departments in the country to promote research activity in the growth and characterization of single crystals. Studies on several aspects of crystallization, superconductivity, spectroscopy, high energy physics, and X-ray diffraction earned the department national and international recognition. The department published over 18,000 research papers of high impact index in reputed national and international journals, leading to the award of 650 PhDs. The department has produced scientists of national, international caliber who have brought laurels to the nation and institution. Many of our faculty members, research scholars and students have won several prestigious awards such as Alexander von Humboldt, DAD, Bioscast, C.V. Raman, AP Science Academy, Telangana Science Academy, Best Teacher Awards, Government of United AP and Telangana, etc. The significance of the conference. Materials are important ingredients in innovations. Materials decide the economy, environment, and existence of any country. Our department has been actively involved in material research since its inception. We have received projects, funding collaborations, patents, and know-how sharing with various agencies in the country and across the globe for carrying out research through designing and fabrication. Our department has always been active in learning about new fields of discovery and imparting them to our students. Today, alternate magnetism, superconductivity, near room temperature, quantum entanglement, IoT, chat GPT, AI, etc. are rapidly advancing fields, and multi-material research has a critical role to play in their growth. This is a great need for high speed, large bandwidth, accuracy and low power consumption materials which require multi combinations of materials having variable physical and chemical properties. We have honored by the gracious presence of our chief guest, the Hon'ble Governor of Telangana, whose vision for education and research inspires us all. We deeply appreciate the unwavering support of the Vice Chancellor of Usmania University and former Vice Chancellors whose dedication to academic excellence and research have made this conference possible. Over the next 3 days, we will witness enlightening keynote addresses, insightful panel discussions, and groundbreaking research presentations. I encourage all participants to engage, collaborate, and contribute towards making this conference a milestone event in the domain of multifunctional materials. As of now, we have received more than 200 abstracts across from the India and global, and another 25 IT talks. Let us embark on this journey of knowledge, discovery, and innovation with a shared vision of the better future through science and technology. I thank the president of this inaugural function for giving me the opportunity to welcome all of you to the ICMMSA 2025 conference. Thank you.
You know, in terms of the development of materials, the physics plays a very crucial role in trying to understand the nature and trying to recreate that kind of nature, that kind of materials artificially, and then making use of those materials for our day-to-day use. And at the same time, I also request is we also looking into the sustainability and then see that every technology, every material, what we looking at, you know, it should be sustainable and easily, and then it should not harm the globe or our environment. And then in this, we can looking at the today's international conference is on multifunctional materials for societal applications. And if you see that a typical example, I will tell you, you know, the functionality for the same material, if you change the functionality, then you can use it for the different applications. Like a good band gap materials for photocatalysis, or any other applications, whether it is an hydrogen generation or it is a self-cleaning applications, or it is even for the battery applications. So which is actually essentially the battery materials is the need of the hour today, and which we see that our ARCI, which is a Department of Science and Technology Research Institute, and which is working on development of materials for this hydrogen and battery materials, solar energy materials, and also the fabrication technologies, additive manufacturing, and also laser processing of the materials. So when we are looking at, you can always tune, use those all those processes, all those equipment, you can tune, and then you can develop the materials. And we need to look at it, the thrust areas which government is also looking at it is a kind of a electric mobility system. We want to say that by 2030 all the two-wheelers will be replaced, and then there will not be any IC engine driven two-wheelers, and slowly 70% or 60% of the four-wheelers will be converted into the electric vehicle. So that is what the big ambition and then big challenge with us, and we need to have materials, developing those kind of materials for those batteries which store energy, and at the same time we also look at it harnessing the renewable energy sources. So we need to also have materials, we need to improve the efficiency, either you improve the efficiency of these existing photovoltaic cells, or come up with a new perovskite cells, or the other CIGS cells which also improve the higher efficiency, so that you can harvest a lot of energy from the per square meter of an area available with us. And these are all, and then other key factor is, which is also clean energy, which are talking about is an hydrogen. And hydrogen generation, because we are looking at a total sustainable system from the water to the water, and then you convert, make hydrogen from the water, and then use hydrogen again for your energy needs, and then so that the end product is water. So it is a circular process, and then you are not going to throw any kind of a waste into the globe. But the biggest challenge is, in terms of three process: hydrogen generation, hydrogen storage, transport, and then hydrogen conversion into an energy. And with these things, you have to work on the improved efficient materials, catalyst for converting those split water into an hydrogen. And then, so these are all the very, I just thrown about very few examples of that, and then you can have a very good challenging. And then other important factor is, in an academic institutions, you always work about, in inventions, and then where you got publications and then the patents. But then converting into an innovation, you need to take it forward to an innovation in terms of a technology, so that it can be easily deployable or easily adaptable by an industry, and then it also can be commercialized, and so that it can contribute to the growth of our country, economy of country, and also can be a global leaders, in terms of Viksit Bharat, what the government of India is aiming. By 2047, India should become a global leaders and then torch bearers in these areas, and then development of these materials.
You are aware that our country has committed to be a net zero economy by 2070. And in order to achieve this immense task, we need to decarbonize our energy sector at a rapid pace. And this immense task of energy transition will require an optimal mix of renewables like solar, wind, and hydro, besides clean and green energy source like nuclear energy. Now, at the forefront of this transformation lies the expanding field of multifunctional materials, which promises to revolutionize the entire spectrum of energy production, storage, conversion, and utilization. From self-healing electrodes in advanced batteries to high-purity silicon for next-generation solar cells, the potential applications of multifunctional materials in energy systems are both diverse and transformative. The energy sector is the only one of many where this advanced multifunctional materials are increasingly being used, and they improve the efficiency and reduce the costs of technological systems, thus benefiting the society and environment in a sustainable manner. In this context, it is pertinent for all of us to sit together in brainstorming sessions and come out with realistic strategies that can provide new and innovative materials with wide applications in a variety of fields.
So without physics, there is no, the transformation, especially the technological transformations, as stands at the intersection of material science and societal advancement. And today, if you look at our mobile phones, our laptops, our fans, our ACs, our everything, our transport system, just now mentioned, the cars, different variety of cars are coming. So these automotive cars are coming up. So the reason is, the lightweight. See, instead of 100 kgs, within 10 kgs with the same strength. So lighter weight and at the same time, sustainable and energy efficient and lightweight. And at the same time, the less cost also. So these are the four, the important aspects they're considering, and a lot of research is going on. And if you look at our flight system, maximum weight to 350. With the lightweight and other the smart material when we are using for the building of a flight, so originally it requires 700 to 750 tons of material, and because of this nanotechnology, because of this smart material and multifunctional material, that weight has reduced to 300 to 350 tons. So that is the beauty of this the multifunction materials. And if you look at your mobile phones, so it appears just the 4 inches by 8 inches or 3 inches. Within that, every material is there. Smart material, multifunction. See, each material, it functions in the different 1, 2, 3, 4 kinds of functions they are taking. So everywhere the world is moving in a faster rate. And smart material, smart infrastructure, and the smart communication, in all these things, the multifunctional materials really playing a excellent role. That is why, to meet the technological changes and technological transformation, without this multifunctional material, it is highly impossible to reach the targets. So the efficiency of the system is improving with the help of multifunctional materials. So multifunctional materials is the order of the day, and everyone should focus on that. And further also, we don't know in which form all the the technological developments are coming up in next to another 10 years. So that is why a lot of scope is there in this particular the multifunctional materials. It is not only just related to physics, it's a interdiscipline subject. So the multifunctional materials, normally we are using engineering side, technology side, in any field. That is why the government of India or even our own state government, they are focusing on the interdiscipline research. They are encouraging interdiscipline research, interdiscipline subjects also. They initiated at graduation level and at PG level and UG level. So we are also focusing on incorporating 30 to 40% of the interdiscipline subjects in irrespective of the special arts, science and engineering, technology, pharmacy, etc. So the multifunctional materials applications in every field, even the biomedical engineering and pharma engineering, medicines, everywhere lot of applications are there. So therefore, this is one of the focused area, and applications are plenty every day from the beginning, morning to evening, or anytime, whatever the material we purchase, whatever the medicines we purchase, everywhere this multifunctional materials applications are there. It's a right title. I appreciate the Department of Physics. McKinsey report, global advanced materials market is projected to $170 billion by 2030. You can assume, so what kind of demand is there for this particular, the global advanced material. So therefore, lot of scope is there. Only our focus is, the energy efficient, lightweight and durable and smart kind of, the material. Especially major applications, aerospace, health and infrastructure, especially civil engineering side, is a lot of applications are there. And at the same time, clean energy side also, so many, even in the textiles and other areas also, these applications are very plenty. And as per the the Albert Einstein, see, because this is related to innovation, what he said wisely, we cannot solve our problems with the same thinking we used when created them. So let us think differently and explore boldly and act decisively. So because when you think differently and laterally, longitudinally, 360 degrees with the critical thinking, innovating thinking and out of box thinking, definitely some innovation definitely we can make, and that innovation should be applicable to the society. So in that direction, each and every student and research scholar and researchers and industry persons, they should focus on that. I really encourage all the participants to engage their questions and deliberations in this particular conference. And 2 days conference definitely will provide many exchanges among industry persons and researchers and faculty members, and some kind of output should be there. So
Honorable Governor and also Honorable Chancellor of Osmania University, Shri Jishnudev Verma, also known as Jishnudev Burman and affectionately called Jishnu Karta, is a distinguished politician from Tripura and served as the Deputy Chief Minister of the state of Tripura. He was prominent member of the North Eastern Council Advisory Committee from 1989 to 1993. Shri Jishnudev Verma played a pivotal role in shaping policies for the Northeastern region. He also served as the convener for the Indian National Trust for Art and Culture Heritage, which is called as INTAC, Tripura chapter, and coordinated initiatives for the trust in the Northeast. He embarked on his political journey with the Bharatiya Janata Party in 1993 and was elected as a National Council member representing Tripura. He held the position of General Secretary overseeing organizational matters for the Tripura Pradesh BJP. In 2018, Jishnudev Verma contested the state assembly election from the Charilam ST constituency, where he garnered an unprecedented victory, securing 89.33% of the votes cast. A multifaceted artist, his creative spirit finds expression in modern art, paintings, and sculptures. His works, infused with vibrant themes, grace various tourist spots, temples, and public spaces, often in collaboration with Sanskar Bharti. A poet and writer of considerable repute, his poetry in Bengali and English has touched the hearts of many. His works, notably featured in his books Children of Water Goddess and Master of Time, are celebrated for their evocative and lyrical quality. He possesses a deep and passionate commitment to tribal development, education, health, and art and culture. Known for his affable personality, he enjoys engaging with people from all walks of life, always making time to connect with the common man. In his own words, his philosophy of life is an opportunity to offer a healing touch to those living on the margins.
I appreciate the Department of Physics, Osmania University, for organizing this prestigious event. The Department of Physics has been a cornerstone of academic excellence since the inception of Osmania University. It has consistently contributed to national and international scientific advancements. The department has played a vital role in fostering young minds and promoting scientific research. Through a series of conferences and symposia, it has provided a platform for global exchange of ideas. Material science is a field that explores the properties and applications of materials. With rapid advancements, materials have evolved to exhibit multifunctionality. Multifunctional materials are designed to integrate multiple properties for diverse applications. They reduce material dependency, enhance efficiency, and enable innovative technologies. Their unique characteristics respond to various stimuli such as heat, stress, electricity, and light. The development of these materials presents exciting possibilities, but also significant challenges. Multidisciplinary collaboration is essential to balance various material properties. Sustainability, cost effectiveness, and durability remain key considerations in the field. The fusion of physics, chemistry, and engineering is crucial for realizing this full potential. Further, research must emphasize environmentally sustainable and energy efficient materials. The application of these materials in electronics, aerospace, and healthcare is transformative. Ongoing innovation will unlock new markets and drive economic growth. I urge all participants to focus on discovering and developing materials that are not only innovative but also accessible, affordable, and sustainable. Their benefits reach the common people, especially those in rural and tribal communities, enhancing their daily lives with practical, durable, and eco-friendly solutions. The pursuit of truth through research should always be applied for the welfare of the world. True knowledge uplifts all and should always be aligned with righteous and collective well-being. I wish that this conference serves as a vital forum for scholars, industry leaders, and researchers. It fosters knowledge, knowledge exchange, collaboration, and groundbreaking discoveries in material science. I commend the efforts of all the participants in advancing this important field. Thank you. Jai Hind, Jai Bharat.
I extend our heartfelt gratitude to our esteemed chief guest and Honorable Governor of Telangana, Jishnudev Verma sir, for gracing this occasion with his presence, for taking time from his hectic schedule to be with us today. Sir, your words are certainly stimulate the scientific community to work towards the constructive development in the area of multifunctional materials to the society and absolutely motivate us all. Thank you, sir. I also express my deep gratitude to our Honorable Vice Chancellor and Chief Partner of this conference, Professor Kumar sir, whose leadership, vision, unconditional support have always guiding us in all our academic research endeavors and in particular at every moment of this conference. Thank you, sir, for your time. Thanks to our distinguished guest, R. Vijay Garu, Director ARCI, Sri Dheeraj Pandey, Director AMD Hyderabad, for their valuable time and readily accepted our invitation, and keynote speaker, Dr. Murlidhar, and panelists for their willingness to share their expertise and insights from this platform. Your contributions add immense value to this conference. Also thanks to Professor G. Naresh Reddy, Registrar of the Usman Institute, Professor Chirendra Nayak sir, VSD to Vice Chancellor, for their support and encouragement at every step in organizing this conference. The man of the show is none other than the conference chair and head of the department, Professor M. Srinivas, who made this conference to realize at this level with his keen interest and meticulous planning. Heartfelt thanks to Professor Karnasagar sir, Dean Faculty of Science, Professor G. Prabhakar, Principal, University College of Science, OU, for their support and encouragement. Thanks to all senior professors